So we're doing question 6, right? The last question for today. I've sent you the questions so you can look at them. I'm not going to rewrite the questions. I'm not fucking insane. So we have sketched below are the graphs of h of x, which is equal to negative 2 over x plus 1, and p of x, which is equal to ax plus q. That means we have to find the values of a and q, right? That's easy, it's doable. So we have 6.1. It says show that a is equal to negative 1 and q is equal to 2, right? So let's do it. So as you can see from the graph, we have two coordinates, a and b, right? And the value of a that we're looking for is actually the gradient, right? This is the gradient. And we know that our gradient is going to be negative. Why? Because our graph is leaning towards the left. Anything that leans towards the left, actually any linear function that leans towards the left, it has a negative gradient. So we know our answer is going to be negative. So we're going to use these two coordinates and find the gradient, which is a. So this is the gradient formula. M is equal to y, excuse me, y yb minus ya over xb minus xa. And then we'll have your yb is 1, and then your ya is 4, then your xb is 3 minus your xa, which is actually 2. So your m is equal to, that is negative 3. No, back the hell up. Okay, right there's negative 1, right? So there's negative 1 right there. So our m is actually equal to negative 5 over 5. M is equal to negative 1, which is therefore a is equal to negative 1. Proved. So now let's look for q, right? We know that p of x is equal to negative 1x plus q, and then we substitute any point. I like b, so I'm going to choose b, which is 3 semicolon 1. We sub it in, 1 is equal to that, and then our x is 3 plus q, and then this is negative 3. No, there's some, relax. Yes, again, right? Our one is, the 1 is negative, right? It's 3 semicolon negative 1. I'm sorry about that. So it's negative 1 plus 3, because when you transpose, the 3 changes the sign q. So our q is actually equal to 2. We proved it. So we go to 6.2. They say determine the values of x for which h of x is equal to p of x. We know that h of x equal to p of x means the points where they touch, or the x values where they touch, right? So we can look at the graph and solve this, right? Or we can do this algebraically. I'm going to do it using two ways. The first one, looking at the graph, and the second one, algebraically. Let's start with the one that looks at the graph, which is quite simple. Right, so we're looking at the graph, right? This is the point where there's an intersection where h of x is equal to p of x. That's also another point where h of x is equal to p of x. But the problem is we do not know these points, right? If we knew them, we just say x is equal to b, x is equal to blah blah blah, yada yada yada, all that bullshit. But we don't know any of that. So all that we're going to do is just solve it algebraically, because we don't have the coordinates there. And I think that's why the question is worth 4 marks. So let's just solve it. right? So we have the expression negative 2 over x plus 1 is equal to negative x plus 2. Then we transpose negative 2 over x plus x. Then we have 2 minus 1, right? So we have negative 2 over x, which is equal to 1 minus x. Then we cross multiply. Then we have x over 1 minus x, which is equal to negative 2. Then we have x minus x squared, which is equal to negative 2. Then you have your x squared minus x minus 2, which is equal to that. So we factorize this. We have x plus 1, and then we factorize it. We have x minus 2, so your x is equal to negative 1, or your x is equal to 2. So these are the x values where our two graphs will meet, and it actually makes sense. Let me go to the graph. Right, this is why I say it makes sense. This is where they meet, right? And a is right there, and a is negative 2, so this has to be negative 1. This is another part where they meet, right? This has to be 2 because b is 3, so it makes sense, right? So I'm gonna go for it. And let's do the last question. Determine the values of x for which h of x is less than or equal to p of x. Right, it's 3 marks. We're actually going to put into practice what I just taught you probably 10 minutes ago. Right, let me redraw the graph. Okay, so you're going to have to forgive me because my graph is not drawn to scale. So let's start with this process. We want the values of x for which h of x is greater or equal to p of x. Remember, we had a there, and a was negative 2 and 4, and we had b right there, which was 3 and negative 1, a negative 1 that I tend to forget most of the time, but not this time, right? So let's start measuring the graph from the left. That's what we do. So we want where h of x is above, right? So let's start here. Remember, you're looking right here. Ignore everything that's on the other side. Keep your eyes right here, right? Right. You're here. That's where you are. Okay, my boy. So we move, right? What is happening? We can actually see that your p of x is above, and we don't want that. That's not the condition that we want. We want h of x to be above. So we ignore that. It's like, okay, cool. If I can move on, and then we move on and move on and move on. When we get to this point, right, we have an intersection where the graph meets the other graph. We have an intersection, right? Do we want the intersection? Fuck yes, we do want the intersection because h of x is greater or equal to p of x. So we mark the intersection because we fucking want it. So see, I'm gonna put the dotted line right there. It's going down. We want the intersection because h of x is greater or equal to p of x, which means somehow these two graphs will fucking touch. So we have the intersection right there. We mark it, and then we move along. We move on the slide. We move on. Funny thing is, h of x will be above forever and ever. It will always be above this effing idiot, this linear function p of x, because look at our graph, it's going upwards, right? So our y values will increase while the linear function is a decreasing function. It's decreasing, but ignore that for now. Follow this. You are here, right? We're moving, but it's above right there, and then something bad happens, right? As we reach the y-axis, what is happening there? do you see our graph tends to go up, right? Forever it tends to go up. And it stops. It doesn't touch the y-axis. So the value here where they touch is -1. The value here where they touch again is actually 2. The x value is 2. I'm not sure. I don't know the y value, and we don't need it. So let me put right there 2, right? So like I was saying, do you notice we are here, right? Ignore the other side. This graph goes up. It doesn't touch, and it will never touch the y-axis. Why? Let's go to our function, right? We have h of x is equal to 2, -2 over x plus 1. So the function has asymptotes. This hyperbola has asymptotes, right? So the vertical asymptote is where x is equal to 0, right? Because the general form of this equation is actually this: is -2x, x minus 0 plus 1, and then you solve it. You say x minus 0 is equal to that, and then you transpose the 0, move it out there. So the vertical asymptote is actually x is equal to 0, and the horizontal asymptote is y is equal to 1. As you can see, that dotted line right there, y is equal to 1. So that's why the graph will never touch here. So we're kind of stuck, right? We're kind of stuck because remember, we're moving it from this side. So when we get here, we stop, right? Let me put on the dotted line. We're stuck here on the y-axis. We're stuck, right? So let's define this region, right, that I'm talking about. It's actually where x, right? We're starting here. This is where they met, and it also met the condition. So from here, do you see the dotted line? If we're going to that side, what is happening to our x values? Our x values are actually getting greater. They're increasing. So x is greater or equal to -1. We say equal to -1 because it touches. And what does our condition say? We want where h of x is greater or touches p of x or equal to p of x. So we say x is greater or equal to -1, right? You always start with the negative number for order. It doesn't matter which number you start with, but for order and for you to be a neat mathematician, just start with a negative number. And then what also happens is we stop here. We stop at this region, right, where x is less than 0. Sorry, let me do it like this for you. So we stopped at the y-axis, right, at the asymptote where x is equal to 0, right? So as we move from this side, from that side, from this side to that side, what happens to our x values? They decrease. That's why we will say x is less than 0, right? That's why we're saying that. So let's go back to our graph and move the fucking pen, because it determines everything. It's a fucking cool pen. So we are moving, right? We're still looking for where h of x is greater or equal to p of x. We move. We cannot see our two graphs. Our graphs are nowhere to be found. It's okay. We keep on moving, right? And then boom, we have the intersection right there. It's also in the condition. Every time you see something that's in the condition, you highlight it. So let's do something. Let's highlight everything, right? Dotted line goes up. At 2, the condition is met. Equal to, they're equal to right there. And we want h of x, which is the parabola. Sorry, the hyperbola. God, I love parabolas. That's why I'm fucking up. So we're looking at the hyperbola, right? Which we want it to be above the linear function. So at 2, It's above. It touches. So our first condition is met. We highlight it, see the dotted line, right? And we keep on moving. And then we see something. The hyperbola is above. That's what we want. And the linear function is below. We're actually like, okay, yeah, right? Everything is happening. We're winning big time. And then we keep on moving, my boy. And this is happening up until infinity, because the arrow right there denotes that this is going to happen up until infinity. Goes like that, right? So it also happens where x is greater or equal to 2, right? Because at 2 it touches. This is the answer to the question, right? It's 3 marks. That's why it's 3 marks. It needs you to think outside the box. So let's use the interval notation. So is x is an element of, right, -1, square brackets, because square brackets denotes that it touches -1 up to 0. Then use parentheses, curly brackets. And here you say 2, up to infinity. With infinity, you always use the parentheses because you never touch infinity. We don't know the number before or after infinity. No fucking idiot does. So this is everything, right? So I did these 2 questions. Actually, it's 1 question, and then the first video is just based on explanations. I'm taking it. I'm actually slow, right? I have to be slow so that I can make sure that you actually get a lot of information. I don't want to, bombard you with a lot of information, right? So yes, I'm gonna post the video right now, so you can ring me up and ask questions. I'm always available. Let me go back to my studies. Bye.